Hello everyone, good evening. I am audible, please. Anybody? Please say yes if I am audible. Okay. Let us wait 5 minutes to join the more participants. Then we'll start the session. Hello, good evening all. I am audible, please. Confirm once. Okay, thanks. Thank you. Okay, thank you. So slide is visible. Okay, that's good. So I'm Om Prakash Maurya from Department of Civil Engineering, IIT Guwahati. Today we will just solve the week 2 question answer NPTEL. So the lecture 1 was about the concept of fluid hydrostatic. Lecture 2 was about the measurement of fluid pressure and fluid hydrostatic force. And lecture 3 was about buoyancy, metacenter, stability and rigid body motion. So sir has completed already these three lectures. So we have lots of questions and also concepts. So we'll start with the first of all with questions. So I think let me share the questions first, because you all people completed this lecture 1, lecture 2 and lecture 3. So let me share the questions. So question is visible. Question number 1. Anyone please try to, or you can, yes, okay, that's good. So please now I will just read the question and you will try to give your answer in the chat box, whether option A, B, C, D, which one will be correct. So Archimedes principle. First question is about the Archimedes principle, is and are. Here maybe is means maybe one option correct and maybe more than one option will also correct. A floating body displays its weight in the fluid in which it floats. Option B, a body immersed in a fluid experiences a virtual buoyant force equal to the weight of fluid it displaces. A body immersed in fluid experiences a horizontal buoyant force equal to the weight of liquid it displaced. Option D, both A and B. So which option will correct? Please you can comment in the comment box. So everyone telling option B, okay. Okay. So please read again the questions. Please everyone go through once through the options, all options A, B, C, D. It might be possible option A, B, C, D, which one will be correct? Okay. Some people are telling option B, someone telling option D. Kedarnath is telling option D. Nachakradas is telling option D. Aryan telling option B. Simranjit B. Kedarnath, okay. Kedarnath has changes the options, okay, no problem. So, okay, Tayyab is telling option D. Okay, yes, D option will be correct because Archimedes principle what telling, just there is a two statement. First statement, the option a floating body displays its weight in the fluid in which it float. This is the first statement, and second statement is a body immersed in liquid. Let me show the draw some figure. So what is actually telling, if water surface is like that, let us suppose this is water. So let us suppose you have put it some here, some block. So this, the volume of this container is V, total volume is V, total volume. Immersed volume is, immersed volume, let's suppose the 60% of total V, and okay, and rest of the out of the water. So the first principle is the whatever the fluid will be displaced by the your body whatever the fluid. Let us suppose if body is immersed that much area in the fluid, that much area is immersed in the fluid, so it will be displaced that much water from this place. This is the first one. Second one is a body immersed in fluid. When you will immerse a body in a fluid, what will happen? A vertical buoyant force will be act on the body. A vertical, not horizontal. Horizontal means this side, not horizontal. A vertical. This is the whole meaning. Now moving ahead on the next question. Okay. Here some explanation is given. Explanation is very well. So let me read. These statements describe the Archimedes principle, named after the ancient Greek mathematician and the physicist Archimedes. First क्या है? What is first option? A floating body displays its own weight in the fluid in which it floats. It means this statement means that when an object floats in a liquid or fluid, the weight of fluid displaced by the submerged portion, the weight of fluid displaced by the submerged portion of the object equal to the weight of object itself. In other words, the upward buoyant force exerted on the object by the fluid is equal to weight of the object, allowing it to remain in the equilibrium and float. So hope you people got it what I want to tell. Now moving ahead on the next question. Next question is about second question. In the hydrostatic or shear free case. Why shear free case? I will explain in the last. Hydrostatic or shear free case of fluid, the pressure change in the horizontal and vertical direction should be filling the blanks and filling the blanks respectively. So please try to fill whether it will be zero or depend on density, your gravity or your change in depth. So please try to give your answer through comment for question number 2. So we have also questions on the based of Archimedes principle. So we'll solve later. So first please try to give the answer of this question. Question number 2. Okay. Nachatra is telling the option D. Okay. Please everyone try to participate in the question answer session. Vishnu, okay, D. Simranjit also D. Other participant, please. Other participant also you give your answer for the question number 2. Okay, Vishnu is telling option D. Okay. Arya Kumar, okay. D option. Aryan Kumar, okay. D option. Okay, everyone telling option D. Okay, definitely option D will be correct because it's a basic equation of the your hydrostatic. So let me show for other student how it will be correct. Hydrostatic or shear free means in your fluid in the hydrostatic condition, that means your velocity is zero. If your velocity is zero, your shear force will be zero. So that's why the shear free case. That's why it is known as also shear free case, hydrostatic condition. So how it will be zero? Because your tau is equal to, or shear stress is equal to dynamic viscosity. Dynamic viscosity will be always available in the fluid because it's a property of fluid. But other things, change in velocity with respect to depth. If your velocity is 0, then change in velocity will be also 0. Oh, sorry. It will be also 0. Del u by del y, it will be also 0. So it means your shear will be 0. So that's why shear free case. Now what is the actual question? The pressure change in the horizontal and the vertical direction. The horizontal direction, your pressure change will be 0 because as per the Pascal law, you know already. If I have one figure very important, in the horizontal direction, not in the vertical, in the horizontal direction your pressure will be same. Whatever your fluid here, there is no meaning. Here is, if pressure is P1, at the same line your pressure will be P2, your pressure here P3. So like that. Okay. So now the other thing, the pressure change in the horizontal and vertical direction. Your vertical direction equation will be pressure change delta P. Oh, why it is happening like that? Delta P is equal to rho GH. So it depend on the your density, acceleration due to gravity, and the depth change. Everything. So option D will be correct. Okay. So one question I want to ask to all of you. Please, just I want to show you in PPT, then I will move ahead. Or let me unshare and share again. Because it's very important, it is related to your hydrostatic conditions. So hope, I think PPT is visible. So what actually I want to explain you, if you will see here, one figure is given. Here this is one figure is given. This is a figure. So here we are trying to measure the your hydrostatic pressure at point A, B, C, D, E, F, G, H or I. So first for your just I want to ask to all of you, option A, option B, option C and option D. I want to put option D. So here pressure at A will be equal to pressure at H, pressure at H is equal to pressure at I, pressure at A equal to pressure at B equal to pressure at C. D option, pressure at H is equal to pressure at D equal to pressure at E. So which option will be correct for this? Please just use your reasoning. What is your thinking on that? And try to give answer. Whether which option will be correct for that? For this question. Okay. Nachatra Das is telling option A, option C. Okay. Other student? Other student, please also you need to participate in the question answer. Okay. RN is telling option B and C. Okay. RN is telling option B and C. Jasprit is telling option C. Okay. Yes, it may be two option may be also correct, or maybe all options correct. So please think, then you give your answer. Sagar Kumar telling option C. Okay. Okay, good. Other student, please also you try to give your answer. If you are joined here, then please try to participate. Then it will be more benefit for you. Other student, please also. Most of the student is telling option C. Question is not visible to me, sure. Okay. Okay. So how? Okay. Please you can zoom if you are using mobile. So please you can zoom out your screen. You can zoom your screen. Then might be possible you may able to see the question. Yes, please. So just quickly you see the question and try to give the answer. I am asking option A, B, C, D in the given figure, and fluid in hydrostatic condition. Remember please, fluid is not moving. Okay. Most of the student is telling option C will be correct. One student is telling option B and C both correct. Okay. Okay, I think no other person will give answer. So let us move with the answer. So what actually I want to tell here, in the horizontal direction, as per the previous question, in the horizontal direction, your pressure will not change. If you will see all options in the same horizontal, same level from the free surface. So pressure at A, B, C, D, E, F, G, everywhere will be constant. Pressure at option C will be correct definitely. Option pressure at D, pressure at E, pressure at F, and pressure at G. One thing you know also, your pressure is depend on what? Rho gh. If rho will be changed, definitely pressure will be changed. Whatever, it will be at same level or other level. So here if you will say pressure at h and pressure at I, this both point in the horizontal plane, both point in the same horizontal height from the free surface, but here your liquid is mercury, here is water. So in this condition your pressure will not be equal. So please remember, always remember, your option C will be correct for this question. Option B will not correct because of the here fluid is mercury, that is the density of this much, 13,600 kg per meter cube, and the your water density is 1000, only 1000 meter cube per second, kg per meter cube. Remember please. So now moving ahead with new questions. So let me unshare and share the question sheet again. Hope question is visible to all of you. Now moving ahead on the next question, question number 3. Question 3 is telling what actually? If you will see the explanation for that, explanation I can also read. In the hydrostatic or no shear or shear free case of fluid, the pressure change in horizontal and vertical direction should be 0 Pascal law and depend on the density gravity and density and change in depth respectively. So for horizontal it will be 0, and for vertical it will be depend on the depth and all. So Pascal law, also known as Pascal's principle, is a fundamental principle in the fluid mechanics. It was formulated by French mathematician and physicist Blaise Pascal in 17th century. This law states that any change in pressure applied to an enclosed fluid is transmitted undiminished to all portion of the fluid and to the wall of its container. Please remember, please hope, I think you are getting. Let's suppose if water is here and it is closed, so if you will make any disturb here, so it will be propagated throughout, here also, here also, here also, everywhere on the wall also. So this is the meaning. The Pascal law state that when you apply a pressure to a fluid in a confined container means closed from everywhere, the pressure is transmitted equally in all direction. Remember please, if your container is closed and you apply here force, so your pressure is transmitted in equally in each direction. Remember please, throughout the fluid and against the wall of the container. This is why, for example, when you squeeze one end of a closed toothpaste tube, the toothpaste is forced out from the other end. So just for example, the given of the toothpaste example here. So now moving ahead on the next question, lots of illustration is given, so will not focus more. So here is the question number 3. Dauki Lake. Dauki Lake, a fresh water lake near the Shillong in, in northeast India, has a maximum depth of 30 meter. Let's suppose a lake is, this is the bed of the lake, and the maximum depth is 30 meter. Okay, and the mean atmospheric pressure is mean atmospheric pressure, so you can write here at P atmospheric pressure, or average you can write also. Average atmospheric pressure is 91 kilopascal. Okay, estimate the absolute pressure. You need to calculate the absolute pressure for this question at the maximum depth at this level. At this level you need to calculate P absolute. So, and the specific weight of water is given, gamma W is given your 9790 Newton per meter cube. So all data is given, you please try to calculate whether it will be on answer will minus, plus or whatever. Just please try to give your answer. Just please, if you are here, you please try to calculate the answer. You use your calculator, scientific calculator, or if anybody the gas gate aspirant, so please you use your gate calculator also, online gate calculator. So it will be more benefited. So please everyone try to solve and give your answer. The question is very basic. Okay, Nachatra is telling the option. Which option? You are telling option C. Okay, okay. Someone telling option B. Okay, Nachatra Das. Okay, C. Okay, considered. Other student, please also try to calculate whether it will be in minus or plus. Jaspreet is telling C. Okay. Okay, okay. Simranjit B. Okay. Aspreet is telling C. Okay. Aspreet has changed the answer options. Okay, no problem. That's good. Good attempt to everyone. Please, other student also want to give answer. You have 1 or 2 minutes. You have 1 more minute. So please try to give your answer. Okay. So Ashtumita Bishwas is telling option C. Tayyab is telling also option C. So most of the people telling option C. Simranjit telling the option B. Okay. So most of the student, let me show you how you will calculate for other student. So basically your what is actually pressure absolute? Pressure absolute is nothing but pressure atmospheric plus whatever the pressure at a point. If it is asking that point, so pressure at 30 meter. So atmospheric pressure is already given 91 kilopascal plus how you will calculate your pressure at 30 meter. So you know already rho, G and H. So rho Z value is given. This is known as rho Z. So rho Z value is your 9790 into H value is 330. So it will be come around. Let me calculate using my calculator. So 9790 into 30. It will be come around your 9 oh 2293700, right? So this is in Pascal. So in kilopascal 293.7 kilopascal. So when we will here you can write 293.7. So it will become 91 plus 293.7. It will be 91. So 384.7. Okay, so option definitely option C will be correct. Okay, that's good. This is the nearest point. So now moving ahead with the next question. Next question is about a question number 4. A manometer is used to measure the pressure in tank. Remember please, sometimes question is asking what is the use of manometer. Manometer is used for measuring the pressure in the tank. The fluid used has a specific gravity of 0.85. Specific gravity of fluid, whatever the fluid, 0.85. Okay, let's suppose a tank is there. In the tank your manometer used for measuring the pressure, so something like that. And the manometer column height is your manometer column height is given 45 centimeter. If the local atmospheric pressure is 96 p atmosphere, local atmosphere, 96 kilopascal, determine the absolute pressure within the tank. Absolute pressure within the tank. So you need to calculate first, please. So same approach you can follow. Firstly, you will try to understand the question, then after you take attempt. So, and as quickly as you will solve, you give your answer. So, okay, option C is telling everyone. Okay. Esprit is telling option D. Anybody want to give answer? Other student, please. Other student may also give your answer in the chat box. Okay. Nachak is telling option C. You have please 1 minute more. If anybody want to give answer, please do as quickly as possible. Okay. Option C. If anybody know the formula of absolute pressure, whatever I was discussed previously in the just last question. So if you know, then you can see the only options. You can able to give the answer because options are given like that. Without solving the question, you can give answer. So I will show you how you will think. Okay, Kedarnag is telling option C. Okay, let me move on the solution part. So here actually in question P absolute means what? Already I have tell you nothing. P atmospheric plus whatever the pressure in the tank. Here is tank. In the previous question your pressure in the at the level of 30 meter. So here is tank. So atmospheric pressure is given 96. Definitely your absolute pressure will be greater than 96. So here which any option? Only C option. So definitely your C option will be correct. But now how you will calculate? So P atmospheric 96 plus tank. So rho is 0.85 into 1000, rho G 9.81 and H your 0.45. Why 0.45? Because it's given in the centimeter. So we'll convert in meter, then we'll divide to 45 by 100. So it will come 0.45. So 96 plus 0.85 into 1000. Oh, I have written 100. So here it will be 1000. 1000 into 9.81 into 0.45. So it will be, okay, first we calculate this part only, then we'll add through the, so anywhere I'm doing mistake, let me check. No, so it is coming around 3, this part is coming 3752.32 Pascal. So in kilopascal 3.752. So 96 plus 3.752, it will come around your 99.75. Or if you will consider up to 2 digit kilopascal. So option C will be correct. Now moving ahead on the next question. Next question is about the center of pressure, question number 5. The center of pressure of a liquid on a plane surface immersed vertically in a static body. Static body means what? Static body of liquid, it is written, very good. Always lie below the centroid of the surface area. Because why it is lies below the surface area? So option A, B, C, D, 4 options is given, and you please read the option one by one and use your reasoning and whatever your knowledge you have understand in the class, fluid mechanics class, and try to give your answer. So I am waiting for question number 5. Which option will be correct? Very basic concept here. So if you have study very carefully hydrostatic topic, then you can very easily give the answer for this question. Okay, Simranjit telling maybe D. Okay, Jaspreet is telling option B. Aspreet is okay. So other student, please also try to participate in the chat box. Use your knowledge here, because you are not in the exam hall. So if you will do wrong thing here or wrong questions here, there is no penalty. But in the exam hall, don't take the negative, please. If you know, then you give answer, otherwise no need to give the answer. So here you can take the attempt, there is no issue. Okay, some of student is telling option D, someone telling option B, Kedar is telling option B, Jaspreet is also telling B. Okay, okay, Nakshatra Das is telling option A. In liquid, the pressure acting in the same in all direction. Okay, First, you please try to understand the question. Question is telling the center of pressure Y when we will immerse any body in the static fluid or a static liquid, why your center of pressure lies below the centroid of the body. This is the question. Okay, please other student also, if you want to give your answer, please give, then I will explain how it will be lies below and above, whether it will be correct or not. Maybe sometimes question may also wrong. So please other student also, if you have 1 minute, more 1 minute, so other student may also take attempt. So this is a very basic question. So okay, so I think no one. Okay, let me discuss. So actually, what is the meaning? Question is asking if it is a water body, you have placed one solid body in the or immersed solid body in the liquid or water, you can say. The center of your centroid of the body is, if it is rectangular, it would be lie here. This is the centroid. Centroid. But your center of pressure is lies somewhere here below of your, this is the center of pressure. Center of pressure. Center of pressure of what? Of liquid on the plane surface. So why this is lie below? Because your variation of your pressure linearly from free surface to the bottom surface, linearly. So it seems like that. So when you will try to analyze the center of pressure or the center of this diagram, the center of this diagram, it will be from here to here. If it is triangular, h by 3, so it will be always below the your center of, or the centroid or center of gravity, you can also say, for a symmetric body. So option D will be correct for that, for question number 5. Hope everyone got it what I want to tell. So now moving ahead with the next question. Okay, the question 6 is about two syringes of different cross sections. Two syringes of different cross section without needles, filled with water, are connected with a tightly fitted rubber tube filled with water. The diameters of the smaller piston and larger pistons are 1 centimeter and 3 centimeter respectively. The diameter is given. If the force of 20 Newton is applied to a smaller piston, then the force exerted on the larger piston is what? So please, if you want to see the options, you can see. just please try to take an attempt and then I will move ahead. So please, this is the basic question. Basic understanding. If you have basic understanding, okay, option C. Here you can use the Pascal law. How you will use the Pascal law, I will explain. Other student may also try to take the attempt. Okay, three student telling option C, 180. Okay, Simranjeet, Jaspreet and Nakshatra is telling option C. Okay. Other student, please also try to solve. How you will take attempt? If you will got the concept, then it will be very easy for futures questions on that concept. If you don't know the concept, how you will take the attempt for new questions, then very difficult. So other student, please try to give your answer. You have 2 minutes for this question, more 2 minutes. So please try to solve with free mind, not you take any pressure. With free mind, you try to solve this question. Okay, other student, please just comment the answer of this question, question 6. Do you have 1 more minute for this question, please? Okay, Vamsi is telling option A. So the question, okay, Sagar Kumar, okay, you are also telling the option A. Okay, I can wait 1 minute more because the student are solving, I think. Some students are solving, so I can wait 1 minute more. Okay, Kedarnath is telling option A. Okay, so now I want to explain. So here actually what is the question? There is two series of different cross section. Let me draw something. Here is the your diameter of this part is 1 centimeter and diameter of this part is 3 centimeter. And two pistons are there. Here is a syringe, but I am drawing the similar case here and tightly packed. There is no gap between for backwater. So, okay. So this is the piston and this side also at the same level. So in the similar horizontal direction, because it is connected with the same liquid, so what is the concept with the same in the same horizontal point, if it is point A, if this is point B, pressure at A will be equal to pressure at B. So this is a concept as per what? As per the Pascal's law. Anyone want to tell something? Okay. So as per the Pascal law, you can write these things in the similar horizontal direction, your pressure will be constant. So pressure at A is equal to force at A divided by area. Pressure at B is equal to force at B divided by area of B. So here you can put. So force at A divided by pi by 4 into 0.01 square equal to force at B divided by pi by 4 into 0.03. Oh, how it is. Let me write here. Force at A is given your 20. Area pi by 4 and pi by 4 will be cancelled out. So 0.01 square equal to, you need to calculate the force at B and your area is here, or you can write in the denominator part 3 square. So force at B is how much? 0.03 square into 20 divided by 0.01 square. So now you can calculate 0.03 square into 20 divided by 0.01 square. It will become 180. 180 Newton. So option C will be correct. Here the understanding is, when you will, if you will make system like that, only you are applying here 20 Newton and you are able to raise, if you will put something here, you are able to raise how much? 180 Newton. if I convert in the kg, so you will divide by 10. So if you will apply here 2 kg, you will put here 2 kg weight. So here you can easily lift 18 kg weight. So if you will make system like that, so overall understanding of this question like that. So now moving ahead on the next question. Next question is very easy question. Pascal's law states that the pressure at a point is equal in all directions. This condition is applicable for what? Laminar flow, fluid at rest, liquid at rest, or turbulent flow. Maybe one or two option also correct. So please try to give your answer. I am waiting. Okay. Okay. So Vamsi is telling option B. Nakshatra Das is telling C. Okay. Simranjit B. Vamsi B. Kedar is also telling B. Jasprit is telling B. Asmita Biswas is telling B. Okay. Asprit also B. Yes, everyone telling B. So definitely. So B option will be correct because Pascal's law is given for fluid, not liquid, because fluid is a combination of both liquid and gas. So option B will be correct. Definitely, you all are right. So now I will take 5-minute break. So I will show you next question. If anyone interested, please try to solve. Then after 5 minutes, I will move ahead on the next question. But for your yes, this is the question. So please read the question if anyone want to read. Anyone want to give the answer, you please give. Otherwise, I will take care of this question after 5 minutes. Hello everyone. So the question 8 is about, so question 8, a liquid filled in a container has a plane meniscus. The meniscus is plane if the theta is the angle of contact, then your theta will be 0 degree, less than 90 degree, equal to 80 degree, or equal to 180 degree and equal to 90 degree. So please think on that and try to give your answer in the comment box. Okay, okay. Most of the student telling option B, someone telling Sagar telling B, or Nakshatra D, and Sagar again telling B. Vamsi D, Benito is telling A, Vamsi again telling D, and Sagar Kumar is telling B, and Asprit is telling A, B, C. No. Okay, you are thinking all option may be correct, right? Asprit. And Nakshatra Das is telling A. Okay. Any student want to comment? Okay. Kedar is telling A. Any more student? Okay. Simranjit telling A. Okay. One more minute you have, please. If anyone want to give answer, you can write as quickly as possible. Okay. So now I will explain. So here your plane meniscus means what? In a tube you have filled some liquid. Your liquid like that. This is the plane meniscus. Concave meniscus is like that. This is the tube. Concave meniscus is like that. This is the liquid, right? Convex meniscus, it is like that. Convex meniscus. So this is concave, convex, and this is plane. Your theta is what? Theta is nothing but, if we will draw a tangent here, so the theta is this. If you will draw a tangent here, your theta is this. Here if you will draw a tangent, is it possible? Because it's plane meniscus. So here, so there is angle between the your angle here it is not possible. So in this case your theta will be 0. In this case your theta will be less than 90 degree. In this case theta will be greater than 90 degree. So for this question your option A will be correct. So lots of I have figure and all. I will upload this question in the doc file or doc folder actually, so you can go through the questions one by one. So now the next question is question number 9. The atmospheric pressure head in terms of water column, whether it will be 760 mm, 101.3 kilopascal, 10.3 meter, or 10.3 mm. Atmospheric pressure head in term of water column. Question 9. So please everyone try to give the answer, and you please everyone try to solve the question first, then you please try to give the answer. Such type of question you can expect in your competitive exam. So currently lots of vacancies are there. RRB JEE I think advertised lots of vacancy in the civil engineering, and also GATE exam coming also. Okay, Sagar Kumar is telling option B. Okay, Vamsi is telling option C. Nakshatra is telling B. Okay, okay, A and B both correct. Okay, Kedar is telling option B. Okay, it might be possible A and B correct, but I will discuss which option will be correct. Don't worry. So other student may also take attempt and also give your comment in the comment box. Whatever your answer will be wrong or correct doesn't matter here. So at least please you try to solve the questions. The main aim of this live session, question answers live session, is try to push up you or try to gear up you solve the questions. The main of this live TA session. Okay, Kedar is telling option B. Other student may also give your answer. You please have 1 minute more. In 1 minute, if any student want to give answer, welcome. Otherwise, I will explain how option A, B, C, which option will be correct. I will explain. Okay, now I want to explain. So here atmospheric pressure head in terms of water column. So how much the atmospheric pressure? That is the average atmospheric pressure. Pascal. This is the average atmospheric pressure, or you can write it is 101.3 kilopascal average atmospheric pressure. But what, like you have uh, try to write the 760 mm of Hg. So similarly, your atmospheric pressure you try to write like something meter of H2O, like that. your atmospheric pressure, P atmospheric pressure was 760 mm of Hg. In terms of your mercury, in terms of water, how you will write? So in terms of water means what? So your pressure is equal to what? Actually rho g h. So pressure is given 10, 13, 25 divided by, if we will calculate from h here. So in terms of water, so it here the density of water and 9.81. So 101325. If you want to write in terms of water, then you will put here 1000 only. If you want to write in terms of other material like mercury, so you will put here 13600. But here is the aim of put water, so that's why we'll write here. So it will come around, let me calculate, 1000 into 9.81. So 10.3 meter of H2O. You can write these things also, 10.3 meter H2O. So this will be equal if you want to write. But here is only kilopascal, but you need to calculate your atmospheric pressure in terms of water, so your option will be correct. Option D will be correct for that, because this is only atmospheric pressure. This is not in terms of water. This is in terms of your Hg 760 mm. So now moving, hope everyone got it. Let me, okay. So now moving ahead on the next question. Next question is about, okay, so this is very important question. So question number 10. While measuring the pressure, if we use an inclined tube manometer in place of single column manometer, the sensitivity of the manometer is increased by a factor. So what is sensitivity? I will explain in this question. And how much, what is the factor of increasing of sensitivity, I will explain. So please, firstly you try to take the attempt with your free mind and try to give your answer in the chat box. Then after I will move ahead with the detailed answer of this question, because this is very important question. And I have explained a solution for this, or I will show you how it will. Okay, first you try to give your answer, then I will tell you correct answer. So please everyone try to solve this question or think. Firstly think, then you solve. So for this question I will give you 5 minutes, please. Okay, most of the, okay, Nakshatra Das is telling 1 by, or that is C option. Okay, so for this question I will give 5 minutes. Other student may try to solve, because this is important, and I will explain this question in very well way. So please, okay, Simranjit is telling option C. Kedar Nag is telling option C. Other student may also try to give your answer in the chat box. Sagar is telling option C. Okay. Most of the student is telling option C. Okay. Still I will wait 2 minutes because I need try to give comment every student here. Okay. Asmita Viswas is telling C. Asprit telling C. Okay. So most of the student is telling C. So hope option C will be correct. I will show you after 1 minute. So other student if want to tell. Okay. Jasprit, you want to ask something? Jasprit, you have raised hand. So if you want, okay. 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 So by mistake, I think. So now I want to show you answer. And what is actually sensitivity? Let me explain you. So let us assume a manometer like that. Right. So in this liquid at same level. So I want to increase something here. And the diameter of both side is same. Remember please. Here is diameter D and here also diameter is D. So when you will decrease this height from this level to when you will come up to that level and you will decrease h, so here h distance will be go up, h distance. So for this your sensitivity is how much? Sensitivity of h, sensitivity of this manometer is h. Sensitivity means what? If you will pressing or if you will decrease with h in the right column or left column, so how much height is increasing in the left column? So here you are decreasing h, so here increasing h. So sensitivity of this type of manometer is h. Okay. Similarly, for inclined, what will happen? Same manometer I want to draw here, but this time is inclined. But this time it is inclined. So same height. Here was initial position and I have reduced h, only h. Like h is equal to here 1 meter or 2 mm. So here also h is equal to 2 mm I have decreased the height in the left column. So what will happen actually if this is theta? So in this or initially was label of liquid is that much. So now what will happen if you will decrease in the left limb by 2 mm or h? So here your distance traveled by liquid in this column, that is the left column, is how much, whether it will be H or other thing. So definitely it will be not H. What will be? So it will be L. Let us suppose L. This is L. So distance will be L. But now when you want to compare these two things, so what is the relation between L and H? How you will calculate? Then you can compare this both thing, that is the single or inclined column. So if you will able to write L in terms of H, then you can very easily compare what is the sensitivity factor. So how you will calculate the your relation? So here, if this is L, this is L, and this is theta, and this is L, so your height will be L sine theta, L sine theta, and this is L cos theta. So how much? When you will measure the pressure, your pressure is rho gh. Rho gh means what? Vertical height, not the slant height. So here we are asking, here we are seeking about the vertical height. So your vertical height here will be how much? Your sine theta, h sine theta, L sine theta, L sine theta. This L sine theta is equal to what? This L sine theta is equal to your vertical height, that is this much height. This height is equal to h sine theta or L sine theta in inclined case. So here what initially I was telling, what is sensitivity? Sensitivity means nothing but if you are decreasing something in the left limb, how much distance travel by your liquid in the right limb. So here distance travel by the liquid in the right limb is what? H by sine theta, because you need to calculate L. So L is equal to what? H by sine theta. So sensitivity increase by, so initially only H. Initially what was the value? Only H. But now H into 1 by sine theta. So it is increased by 1 by sine theta. Hope every student is got it. What is the concept behind this? So the option C will be correct. Yes, everyone was correct. So I have lots of explanation about this, so please every student go through the explanation if you didn't get by my explanations. So here one example is also given, so you please follow the examples. Lots of figure I have put it here, so you can go through one by one. Now this is very interesting question. Question number 11. A block of concrete weighs 400 Newton in air and weighs only 250 Newton when immersed in fresh water. Remember please, in air if you will weight something it will be 400. After putting the water it is only 250 Newton. Where is the other force? Here you will apply which principle? I will explain you. First you try to take the attempt. The specific weight is 9810. Specific weight of what? Fresh water. What is the average specific weight of block? Kilonewton per meter cube. So everyone please try to give the answer. So hope everyone got the previous concept. For this question you please everyone try to take attempt. You have 5 minutes. Such type of question you can expect in the coming gate examination in 1 marks or other examination also. So everyone please try to give your answer in the chat box. Question is very simple and little bit conceptual. So please try to solve this question and write your answer in the comment box. Maybe options wrong. If anyone getting the another answer not matching with the options, so please you can write your answer in the chat box also, no problem. Okay, Vamsi is telling option B. Okay, I will check. Let us wait for other response. So everyone today participate in very well manner. Okay, Nakshatra Das is telling 2.66. Okay, I will check whether option is correct or wrong. Okay, that's good. You can also check your calculation once. Maybe somewhere point uh, you are doing mistake somewhere in calculation. Just you check once. Other student, please also try to give your answer. You have more 3 minutes for that. Okay. So okay, Vamsi is telling you are getting the 26. Okay, you are getting in Newton per meter cube, but here I am asking in the kilonewton. So as per your answer, option B. Okay. And Kedar is telling also option B. Okay. Okay, Vijay is also telling option B. So many student is telling option B. But I am waiting for other student also, because some students solve very fast, some student very slow, little bit middle. Some students try to understand the question first. Yes, everyone need to follow one procedures. First try to understand the question, what is asking, what is the given data, then you try to take the attempt. It will be very easy. So last 1 minute, if anyone want to give the answer, you have 1 minute only. Then after I will solve. Okay. Now I want to solve the questions. Okay. Nachatra Das is also telling option B. That's good. Good attempt, everyone. Now I will try to solve. So here actually in air, let's suppose this is a air. In air, one block is there. The weight is 400 Newton. In water, when you will put this block in water, weight is only 250 Newton. Where is the weight? Weight is balanced by what? Your force of buoyancy or buoyant force. So what is the average specific weight of the block? So here the question is, this is gamma B for block, gamma is a specific weight is showing. A specific weight is nothing but rho g. What is the density of block and the acceleration due to gravity. So how you will write your concrete weight, that is weight, or gamma you can also write weight by volume. Weight by volume you can also write. So for gamma B, your weight is in air is 400 and volume in air, because volume is not given, so you cannot do this attempt. So as per your Archimedes principle, what is your Archimedes principle and how you will take attempt this question? So you know already the concrete weights or a specific the concrete weight. So weight with this formula only, what is your gamma into volume. So this is right only, gamma into volume. So it is given your 400 Newton in air. But when you will immerse in water, what is the weight? When you will immerse in water, so it is coming around gamma B into gamma W into volume is equal to what? 250 Newton. So how you will then you now you can very easily calculate. This is the equation 1 and this is equation 2. This is gamma B and this is your volume and this is volume. When you can divide this gamma B equation 1 divided by equation 2. So gamma B minus gamma W is equal to volume will be cancel out, 400 divided by 250. So from here you can easily calculate 250 or 250 gamma B equal to 400 gamma B minus 400 gamma W. So 400 gamma W, when we will minus 150 gamma B, so gamma W is nothing but, it is given already in the question, 9810. So 400 into 9810 Newton per meter square, remember, and 150, and this 400 is given in Newton. Okay, that's everything is fine. And this is gamma B. When you will calculate, it will come around 26. Yes, it is coming 26.16. So like that you can very easily calculate. So here is concept is nothing but, concept is what? Your formula of specific weight is equal to nothing but weight divided by volume. Another concept is, when you will put in your in the water, so your, that is as gamma is changed by what? That is reduces by gamma W. So initially gamma 1 like that in air, gamma 2 is like that, gamma minus gamma W. So how this gamma W come in picture? This is come in picture for the buoyant, because, and why it is minus? Because this is the up downward, and gamma or your force due to the buoyant, it will be upward direction. So definitely if you are taking the downward in positive, then it will be upward thing will be negative. So hope I think everyone got it. Now moving ahead with the next question, question number 12. A vertical rectangular gate 2-meter wide and 2.5-meter height is subjected to water pressure on one side. The water surface being at the top of gate, okay, your D. The gate is hinged at the bottom and is held by horizontal chain at the top. It held by horizontal chain. Please remember. Calculate the tension in the chain in kilonewton. Which option will be correct? A, B, C, D. Please, this is a very basic question, or little bit conceptual. Here your strength of material concept will also use. Mechanics, solid mechanics concept will be used here also. So please try to take the attempt, then I will explain the answer. You have 5 minutes for that. Okay. Simranjit is telling option C. Okay, I will check. Other student may also try to give your answer in the comment box. Please everyone try to solve, and whatever you getting, write in the chat box whether option is matching or not. Don't worry. Okay. Jasprit telling C. Asprit is also telling C. Okay. Okay. Asmita is telling C. Okay. Now I will explain. So here is very basic thing. If you will read question very carefully, then you can imagine one thing. What? One gate is there. I am showing you only side view, and a horizontal chain is like that. Horizontal chain. One hinge is here, right? So calculate the tension in the chain and your water in this direction only. Your water. So your pressure distribution like that. Definitely your pressure distribution will be like that. Wide is the gate width is how much? Gate width is given like that. It is 2 meter. And throughout the water is there. Here water, water. Everywhere water. Like back side. This side nothing. 2 meter width and height is 2.5 meter. 2.5 meter. Okay. And one side only. The surface, water surface being at the top of the gate. Okay, water surface up to that. That's why I have drawn here. The gate is hinged at the bottom. Here is hinge and is held by the horizontal chain. Definitely. Calculate the tension in the chain. So how much tension? So tension means what? If you will something try to tie with chain, try to tie up the gate with this chain, so your tension will be in this direction. Definitely in this direction. And your center of pressure of this diagram is H by 3. So maybe lie here. So 2.5 divided by 3. Okay. So now you can take the moment here. So this force, let us suppose pressure P, the pressure diagram. So now you can here write very easily your T into 2.5 because this is the whole, and P into your 2.5 divided by 3. And from here you can calculate your tension. P into 2.3, 2.5 and here 2.5 divided by 3 into 2.5. So it will be cancelled, divide P by 3, your tension. PF, that means pressure force, I want to write here. So this is the whole concept behind it. The whole concept. Right. So how you will calculate your, I was writing the PF. So here FW is written. So FW, how you will calculate FW? So FW is nothing but FW is the area of this diagram. So this is the triangular. So first of all you will write half into 2 meter width, height 2.5 into volume. That is volume means you need to multiply with length 2.5. So this is whole thing volume. Now 9.81. Or for moment it is 2.3, nothing. So you need to calculate this. How much? So 2 will cancel. So it will come around. This is 6 to 5. So 6.25 into 9.81. So if you will calculate 6.25 into 9.81, it will come around your 61.31. So now you can put here 61.31 divided by 3. So it will be your 20.43. 20.43. So your correct answer is B. So remember please how you will take the attempt for this question. So now moving ahead with a new question, another question. Another question is question number 13. A 15 centimeter length of steel rod with a relative density of 7.4 is submerged in two-layer liquid. Two-layer liquid. Remember please. Layer of liquid is 2. Here is the layer. The bottom layer is mercury and the top layer is water. The depth of bottom surface of the rod from the liquid surface in centimeter. What you need to calculate? The depth of bottom surface of the rod. Depth of bottom surface of the rod in centimeter you need to calculate. So the relative density is given here 7.4. Relative density is nothing but it is given 7.4. Okay, I will explain. Please first you try to take attempt. Within 2 minutes if you want to give answer, anyone please give, otherwise I will show. Okay, so please. Okay, we have very limited time, so I want to show you the answer first, because so how you will take attempt. So you know, as per the your Archimedes principle, so your first of all in question is given already, the length is 15 centimeter. Length is 15 centimeter and density is this, relative density. So 15 centimeter into relative density 7.4 is equal to what? How much immersed in water? That is, let us suppose immersed in mercury is X and immersed in water is 15x. Rest of the will be immersed, so your X into relative density of what? Mercury. 13.6 plus 15 minus X relative density of what? Water. So now you can calculate very easily. So when you will calculate, your answer will come out 7.62. So the next question is very easy. Equal volume of liquid are poured into the container. Let's suppose you have the two container and 1 and 2 container. The area of the cross section of container 1 is double the area of cross section of container 2. So area of container is like that first, and area of container of is double. So here is 2A and here is A. Definitely when you will put the same volume, for the same volume height will be more. If you are putting the V liquid here and V volume liquid here, area is less in this case, so definitely your height will be more compared to the previous one. So this is the concept. If P1 and P2 denote the pressure exerted at the bottom, pressure exerted at the bottom of the container, and F1, F2 are the forces exerted at the bottom of the container, then which of the following will be correct? So P1, P2, F1, F2. Right, so what is the concept here? Actually, your pressure is depend on what? Force by area. Force is depend on what? Density of liquid. As you know already, your force is equal to nothing but, and mass is equal to nothing but m by v. Rho is equal to, so mass is equal to rho v and g. So your force is taken rho volume and g. There is nothing relative relation between the h. So F1, F2 definitely will be equal if the volume is same and density is same. But what about the pressure? Pressure is depend on area. So P1 is how much? P1 is equal to force F1 divided by 2A, and your P2 is equal to F2, or you can write, if F1 F2 is equal, so you can write F1 divided by A. So P1 is equal to F1 by A is what? F1 by A is P2. So P2 by 2. So P1 is equal to nothing but 0.5 P2. Hope everyone got it, what I want to say. Now the last question is nothing but, last question is very easy. The atmospheric pressure at the free surface of the freshwater lake is given as this much. The gauge pressure and the absolute pressure at the, this is very easy. So your gauge pressure is how much? Pressure gauge and pressure absolute at the depth of 2 meter. So here P atmospheric pressure plus P gauge. So P gauge, how we will calculate? Rho GH. Rho is 1000 into your G 9.81 into 2, and so atmospheric pressure is given already, and you will add this data, so you will get the P absolute, and here is the P gauge. So you can very easily got it. So this is the whole calculation. So your option will be correct, 19.62. Option A will be correct for that. So hope everyone got it, what I want to try to say in this question. So thank you for today to all of you. We'll meet again in the next class. on next Monday, the same time. Yes, please. Sagar, if you want to ask. Yes, what you asking, please, again. Yes, you can access very easily. Okay, if you have link or not. So I think from the NPTEL side you got it, the link of this. Everything you will got it. YouTube link and the question answer link. Everything you can got it. So you didn't get? Okay, okay. Let me share you. Okay, okay. Don't worry. So you can go with this link. Okay, you just go with this link. You will get it. Okay, if anybody want to, yes, please. No, these NPTEL questions are designed for your concepts, not for focusing on the GATE exam only. Yes, please. Yes, yes. Okay, okay. You are asking the NPTEL lectures for enough for the GATE exam. Yes, it is more than GATE exam. It is more, but you need to the practice the previous year question. This is the main thing, because when you will solve the previous year question, you will get what type of question people basically the gate committee want to ask you, right? And student is asking, Jasprit is asking, no, what about the attendance? So attendance will not take. So don't worry about the attendance. So thank you everyone again. We'll meet again in the next class to on Monday, not tomorrow. So thank you. Okay, thank you.